and look how busy it is. Just taking you guys through, getting to one lecture, now I'm going to another. It's pretty fast-paced. You just got to move from one place to another, but I love that. It's all about that efficiency of learning and getting it done.
Thank you so much for honoring us with the lecture in 2019 on behalf of the ACSM as a token of our appreciation.
Just saw Dr. Brooks speak about the Lactate Shuttle. It's very, very provocative, very interesting. Coming full circle, you know, he spends a large portion of his career studying the Lactate Shuttle. I actually have his exercise physiology book from college. It's a 1996 text. Unbelievable. I got to see him speak.
Cori's cycle, also known as lactic acid cycle or glucose lactate cycle. Lactate formed from glycolysis in skeletal muscle under anaerobic conditions and erythrocytes. It is the process of transportation of lactate to liver and kidney where it reforms glucose is known as the Cori cycle or lactic acid cycle. Uses: prevention of accumulation of lactate in the muscle, reutilize lactate from muscle and erythrocyte for gluconeogenesis. Cori cycle involves liver and kidneys, muscle, red blood cells.
So here's a fascinating study on handgrip fatigue and forearm girth in intermediate sport rock climbers. And what's fascinating is, you know how in CrossFit when they shake their hands out, like when they're hanging up, you know, on those when they're climbing, and they say, like, you know, their forearms get blown up, or they're pumped. Well, here what they find is that when the forearm girth goes up, so in other words, this is known as transient hypertrophy, then their grip strength goes down. And in fact, it shows here that the increased forearm girth and decreases in muscle strength suggests that rock climbers should carefully monitor recovery time between bouts. That's why they shake their hands out and they hang with one arm when they're doing those climbs and so forth, because they know that when their arm gets pumped like that, shaking it out might actually dissipate and help with blood flow, because blood starts to accumulate, starts to pull, and you get pumped and you just get fatigued. So I thought this is a fascinating study right here.
Louisiana. It was a great presentation. I wanted to ask you, what's the optimal time range to exercise without incurring misalignment of the circadian clock? In other words, like a earliest, latest, and what would be a time that creates misalignment?
So honestly, we don't have the data to make that conclusion. I mean, I can sit here and speculate, which could get me into trouble. But so again, the clock is not precision. So I can tell you what I do with my own life. I mean, I suppose. So my exercise, I'm a morning person, so I get up early in the morning, and I feel best, both my ability to exercise, I feel metabolically more aligned. I don't want to use the word aligned, but I feel metabolically better to do what I like to do, which is running in the morning. And so that's when I'm going to do it. And I feel better throughout the day, you know, all kinds of the normal benefits of exercise. I've never been one to sort of optimize performance, so that's not really been my goal with my exercise program. So I think, and I can remember, again, back when I was a graduate student in Michigan, I used to run a whole lot more, but there were like afternoon running for me. I could do it, but it was hard as heck. I always felt like I was metabolically out of line. And it never made sense to me. You know, I played with all kinds of variables, what time I ate lunch, all this, and nothing ever worked for me. And I know other people that run commonly in the afternoon. So basically, I've maybe confused you more than helped you with your question. But
no, it varies by, like you said, some people prefer morning versus afternoon. I guess the next question was, is there a time where it's potentially unfavorable to the circadian, like for instance blood pressure, glycemia, and so forth?
That actually has not been tested. So this has been a discussion I've had with a few people. So this is one of the challenges. There's two challenges. Well, there's probably more than that challenge, but one of the challenges is that the studies that have done time of day and training, let's say in the hypertrophy response, they've trained the people. They're still training the people during the active phase. Okay. And again, I want to get to the point that the window of time is not a half hour here, a half hour there. But so they haven't seen much difference in terms of the amount of hypertrophy that occurs. What they haven't done is train the person at 8 a.m. or let's say 2 p.m. and 2 a.m. And I mean, this is the kind of stuff we can do with animal models and ask, do you get the same kind of training adaptation if you do the same bout of exercise but at 12 hours opposed. We don't know the answer to that. It may be exactly the same. It could be very, very different based on what we know about transcriptional changes in muscle, just based on the clock regulation.